Between the fiery ambition of Mars and the colossal might of Jupiter lies a silent, sprawling cosmic highway. This is the asteroid belt, a vast ring of debris where millions of objects, ranging from dusty pebbles to dwarf planets, endlessly orbit our sun. For decades, we imagined it as a chaotic, impassable field. The reality, however, is far more empty. The average distance between asteroids is over 500,000 miles. They are less like a gravel road and more like lonely islands of rock and metal, separated by an ocean of vacuum. These are the leftovers of creation, remnants of a planet that never was, torn apart by Jupiter's immense gravity. But this cosmic rubble doesn't always stay in its lane. A gravitational nudge can send an asteroid tumbling inward on a potential collision course with other planets, including our own. Earth bears the scars of these encounters. The most famous is the Chicxulub impactor, a 6-mile-wide behemoth that struck the Yucatan Peninsula 66 million years ago, ending the reign of the dinosaurs. More recently, in 2013, the world watched as a 60-foot object streaked across the skies of Chelyabinsk, Russia, exploding with the force of 30 atomic bombs, a stark reminder that our solar system is an active place. But not everything that crosses our path is from our own neighborhood. Some visitors are from much, much farther away. On July 1st, the Atlas Survey Telescope in Chile spotted something extraordinary. Named 3I/Atlas, it was only the third interstellar object ever confirmed to have entered our solar system. What makes astronomers certain? Its trajectory. The object follows a highly hyperbolic orbit, meaning it isn't bound by the sun's gravity. Its path is so extreme that it massively outpaces the two interstellar visitors that came before it, Oumuamua and Borisov. This visitor is not just passing through, it's screaming through space. And unlike the others, this one is huge, estimated to be around 9 to 12 miles in diameter. It's a true cosmic giant. Shortly after its discovery, signs of a comet-like coma and tail became evident. This wasn't just a rock. It was a cosmic snowball, carrying the chemical signatures of its home star system, countless light years away. While it poses no threat to Earth, its journey will bring it just inside the orbit of Mars before it slingshots around the sun and heads back out into the void. For scientists, 3I/Atlas is a monumental opportunity. It's a tangible connection to another star system, a free sample delivered right to our doorstep. We can't send a spacecraft to meet it. It's simply moving too fast, but our telescopes can study it intensely, and it's likely just the beginning. The reason we are suddenly finding these interstellar wanderers is that our technology is getting better. With new observatories like the Vera C. Rubin coming online, we are poised to discover many more. As one astronomer put it, get ready for 4I, 5I, 42I. From the familiar rubble of our own asteroid belt to these giant messengers from distant stars, each object reminds us that we are part of a vast, interconnected cosmos with new discoveries waiting just beyond the next sunset. Let's begin a journey to understand true cosmic scale. We start at home, on Earth, a world that seems vast to us. But the first step on our journey reveals our local giant, our own sun. It is a roaring furnace so immense that over 1 million planet Earths could fit comfortably inside. The sun is a true monster, accounting for 99.8% of all mass in our solar system. By any measure, it is a king. But now we must leave this king behind. Our real journey takes us 20,000 light-years away, past shimmering nebulae and stellar nurseries, to a crowded star cluster in the constellation of Scutum. Here, we find a star that dwarfs our own sun so completely, it forces us to reconsider everything we thought we knew about size. Its name is Stephenson 218. It is the largest star known. Its size is difficult to comprehend, with an estimated radius 2,150 times that of our Sun. If you were to place it at the center of our solar system, its surface would extend beyond the orbit of Jupiter, reaching all the way out to Saturn. Any planet in our inner solar system would be nothing but a vaporized speck deep within its stellar atmosphere. Its volume is so immense that nearly 10 billion of our suns could fit comfortably inside it. So why is it so enormous? Stephenson 218 is a red supergiant, one of the most luminous ever found. It is a star nearing the end of its life. For millions of years, it has burned through its fuel at a furious rate. Now, the immense outward pressure from its intensely hot core has inflated its outer layers to this incredible size. Despite its size, it's actually quite cool for a star, with a surface temperature of only about 3,200 Kelvin. This is what gives it its distinct fiery red color, but it compensates for this low temperature with sheer scale, shining with the light of almost 500,000 suns. And because it lives so furiously, it will die spectacularly. A star this massive won't simply fade away. When its fuel finally runs out, gravity will win the final battle. In an instant, the star's colossal outer layers will come crashing down onto its core, triggering an explosion of unimaginable violence, a supernova. For a few weeks, Stephenson 218 will outshine most of the stars in our galaxy combined, blazing as a beacon across the universe. Then, silence. The great titan will be gone, and in its place, its core, crushed by its own immense gravity, will almost certainly collapse into a stellar mass black hole, a silent, invisible tombstone marking where a giant once reigned. But this death is also an act of creation. The explosion will seed the surrounding cosmos with the heavy elements forged in its heart, the very gold, carbon, and iron that will one day form new stars, new planets, and perhaps new life. The ghost of the universe's largest star will become the building block for the future.